Welcome back to the observer pattern, video number 2. Now we're going to apply the observer pattern to something else. So before we have actually made this object pool game example. So let me just show you. So I had this game running where we have these big stones that are flying around and we put them in an object pool. Let's just make them bigger. It looks kind of weird. So let's go to here, 25, better. Looks better, right? So now we have this. So what I wanted to do is I wanted to use the observer pattern, and let me show you why. So one of the things I don't like about this example is the fact that I think somehow it's not very smart that this main controller is actually controlling this. We should have this in another class. This is pure business logic of some kind, right? I think drawing is fine and calling the move is fine, but checking if it's out of bounds, I think this should be somewhere else. And then I'm thinking, who actually knows if it's out of bounds? And it's only the main controller that knows, but it can delegate that responsibility. And I think it should delegate the responsibility to the rock itself. I think the rock should actually know when to die. When it's not really dead, it's going into a pool. But I think it should actually delegate that responsibility and say, if you get out of bounds, my friend, please kill yourself. So we'll do something like that. So this release stuff here. So what I'm doing here, I'm seeing the rock pool. I'm seeing that as the kind of observer. So I want the rock pool to observe on all rocks. And the way that it's observing is that whenever the rock detects that it's out of bounds with something like this, it will notify the rock pool that it needs to be released. So instead of calling update, I will just say release directly. Okay? So it's not entirely the observer pattern, but it does look like it in some ways, important ways. So let's try to take this out. So this part, I want this inside of my my rock. So let's go for the rock. So in order for this to work, rock needs to know about who observes it. And I'm going to do a simple version. You can probably figure out yourself to do it more complicated. So I'm not going to use a list. So there can be only one observer in this case. So I'm going to say private rock pool. And I'm creating a binding to the rock pool here. So pool. Let's just call it that. And then we have to have the bounds as well. So I'm going to create an int called bounds x, and I'm going to say private int bounds y. And then I'm going to recreate the constructor, so I don't have to rewrite it. So that's it. And maybe we should be able to set the bounds as well. So just go for alt insert, getters and setters, and like that. Yeah, we can set the pool, get the pool, that's also fine. So that's it. So we just expanded that a lot. So now, of course, when we create the rock in the rock pool, we have to put something else there. We also have to put the rock pool and the bounds. So the rock pool, that is really easy, right? It's just using this. And the next problem is actually the bounds. We don't know about that because the rock pool doesn't know about the bounds. So we have to add that here. So we're going to say bounds x, bounds y. And just add them here. Like that. So now we move the problem once more. Let's just put this on another line. We put it to the main controller, and fortunately it's very easy for the main controller because it does have access to this information. Get width and get canvas, well, canvas get height, like that. Yeah, and height and width are double, and we can easily convert that. That won't give us any problems because it's just an estimate, and you can't have half pixels anyway. So let's go for that. So that's it. So now actually, when we create a rock, it actually knows about the bounds. So the next thing is that whenever so the rock needs to check to see if it's out of bounds. So we'll create a method check if out of bounds. So now we need the code from in here. Sorry, from the main controller. This code here. So we take that completely out because we don't want that responsibility here. So if it is released, it should just be released, I think. So we go in here and we say check if out of bounds. Because we are here, we don't need this, so we can just say if bounds x, and we can remove rock here, and we can remove rock here. Let's just, and then bounds y. Okay. That's it. And then we say rock pool get instance release rock. It's of course itself it wants to release. So it's kind of like when we call this update function and add itself as a parameter to that. Except we coupled them really tight here because the rock uses the rock pool itself, right? So we can never change this. We should use something like an interface. The rock pool should have something like an interface that said rock observer or something like that, so that we could observe on rocks. But yeah, this is how it's going to be for this video. So I'm just showing you to make you understand that one of the great ideas behind this is that you invert the relationship between rock and rock pool, in the sense that rock itself will look at itself and see if I'm out of bounds, I'm going to notify someone that is set that I need to notify, and in this case the rock pool. So let's see if it works. So it doesn't work. Just goes bananas, right? Shouldn't just keep going this number. So I probably did some kind of error here. So let's see what's going on. So let's start here in the main controller. So I'm saying, I think I know. So here in rock move, I'm actually just moving. So what I need to do is I have to check each time after I moved, I check if I'm out of bounds. If I'm out of bounds, I release myself. So now it stops at 107 and it starts taking from the queue. So all is good. So that's it. That's how you can use something like the observer pattern also on this example here. Not the most obvious example, but I think it's a nice way of inverting the responsibility of disassembling itself, like saying you're bound to your parent rug pool somehow, and you're going to say whenever you need to be destroyed, and then it will destroy you. So in this case, this makes it much simpler for the client, because the only thing it does now, it gets the list of rocks from the rug pool, and then it just moves. And the rocks themselves will just release themselves whenever they need to. So that was it with the observer pattern. Quite simple pattern. You can use the Java one, you can use your own brew. You can also extend the Java implementation or whatever you need to do. So it's up to you. You probably also noticed that it's used widely in JavaFX. So for example, as you've seen before, if you use the observable array list, which is part of sorry, it's just observable array. You can use the observable array. There's observable list interfaces, and there's a lot of different kinds of observables in here. And you probably already know that if you use one of these observable arrays or observable array lists, you can actually put them into the controls on your GUI, and they will automatically notify when they change. Then your GUI will also change, and it's really nice to bind them like that. And you've also tried, probably, if you have properties like let's see if we can find something on the graphics context. No, maybe not. No properties here. Let's go for certainly is on the main pane. So for example, if you look at one of these properties, for example background properties, you have the ability to bind. This also uses the observer. So when you bind to something else, it will notify whenever it changes, right? There's also add listeners. Listeners and event listeners are also observers. So they listen for changes, so whenever something changes, you'll get notified with the listener will get notified. So it's something that is used a lot all around. And it's a nice, simple, very well working idea. So thank you, and see you in the next video.